What is the strategic core of self-driving cars? It is vision technology. In this episode, let's talk about LiDAR. You may know that in 2018, Uber agreed to pay $245 million to settle with Waymo after they were in court over the theft of LiDAR secrets. What are the advantages of LiDAR? LiDAR is simply a light sensing technology that uses a laser and a receiver to create a 3D map of the vehicle's surroundings. If fully autonomous driving is achieved, the use of LiDAR allows for more effective avoidance before a vehicle collision occurs. Cameras have good resolution and color information, but are much less effective in poor lighting conditions or in bad weather conditions. According to Dussan, founder and now CTO of AEye, even in great lighting conditions, cameras have contrast instabilities. For example, a white-clothed person in front of a white wall can be hard to detect. Cameras also have range object ambiguities. For example, a bike on the back of a semi-truck looks like a bicyclist to a camera computer vision algorithms, even it is just a picture. Radar has good performance in adverse weather conditions, but does not provide sufficient range resolution, nor does it handle the certainty of object position due to multipath very well. LiDAR fills these performance gaps and is currently the only sensor that can provide the deterministic location of obstacles in front of the vehicle. Using LiDAR can help a vehicle's path planning system make safer driving decisions. Why did Tesla's Elon Musk complain about LiDAR? As we know, Elon Musk complained publicly in 2019. LiDAR is a fool's errand, and anyone relying on LiDAR is doomed. Currently, Tesla cars use Tesla's visual system based on 2D cameras. One of the reasons is because the price of LiDAR is expensive. In the year, a 64-line LiDAR that could meet the needs of the L4 level autonomous driving costs around $80,000 to $100,000, more expensive than a Tesla Model 3 at that time. Another reason is that Elon Musk also believes that 2D cameras with brains can act like people, so he thinks LiDARs are unnecessary. Is there any company that can solve the above technical problems? Yes, today let me introduce AEye, a company established in 2013, funded by investment institutions including Kleiner Perkins and General Motors, as their lead investors, with Airbus and Intel Capital following on. AEye has created the IDA, Intelligent Detection and Ranging Platform for Vehicle Autonomy and Robotic Vision. It provides a more reliable robotic perception than human vision. For example, IDA can selectively revisit any selected object twice within 30 microseconds, a 3,000 times improvement in efficiency. They can also do instantaneous resolution enhancements. So, when they detect an object that has only a few points, they can quickly revisit the object before it has moved even a centimeter and super resolve it. Currently, they are the only ones with that capability. Thanks to Louis for the demo video. AEye went public on Nasdaq in August 2021 through a merger with Spark Special Purpose Vehicle CF Finance acquisition. Combining high dynamic spatial resolution with very long-range detection capabilities, they can detect vehicles within 1,000 meters. Who founded AEye? The founder and former CEO of AEye is Louis Dussan, who received his undergraduate degree in electrical and computer engineering from the University of Texas. After graduation, he joined NASA's Jet Propulsion Laboratory as an engineer. Later, he joined Lockheed Martin as a staff engineer, responsible for research in adaptive optics, remote sensing, ultrafast lasers, algorithm development and control software. During this period, he pursued 2 master's degrees at the University of Central Florida, one in laser and optical detection and the other in quantum optics. In 2011, he started his PhD in computer physics with a concentration in quantum communications, quantum entanglement, and condensed matter physics. In 2014, he founded AEye. In October 2020, AEye changed the management, and Louis Dussan became the company's president and CTO because he wants to spend more time developing advanced vision hardware, software, and algorithms that act as the eyes and visual cortex of self-driving cars. What is the current status of AEye? AEye's stock price was $1.8 on June 29, 2022, down 85.9% from its IPO. One of the reasons is that AEye has not been profitable. In addition, it is not enough to rely on LiDAR alone to build the perception system of self-driving cars. Autonomous vehicles require fast, accurate, and complete perception systems. Now AEye adjusted their business model and has partnered with Continental Group, a German-based multinational automotive components company. Their AI-based long-range LiDAR system can be expected in production by 2024. Some called 2022 the first year of LiDAR popularity in China. According to reports, 14 of the 20 vehicles expected to be launched in 2022 in China are expected to be equipped with LiDAR, and 14 of them are expected to be equipped with the domestic LiDAR solutions. As technology continues to advance, if the size, weight, and cost of in-vehicle navigation-grade LiDAR can be further reduced, the market will be huge. Let's wait and see.
We all have been promised, autonomous vehicles for a long time, autonomous robots that help around the house. And so I wanted to really create a robot and an autonomous vehicle because I felt like the technology was there and we were just not doing it right.
I was talking to him and he started to explain a very similar vision of how he saw the future of autonomous vehicles and how he saw specifically the knowledge that he'd accrued from his aerospace and defense background and applying it to implementing this system that we now call LiDAR.
There's nowhere else in the world that you're going to find advanced concepts, targeting systems, information surveillance, reconnaissance, remote sensing than aerospace and defense. Those concepts and ideas are transferable across many, many different things, especially robotics and especially perception. And so that had a huge influence in the way I thought about what we were doing.
My first impression was, here's a really smart guy. He's got very relevant experience, particularly for military projects. And the ideas that they were using in those projects made perfect sense.
I wanted to create a perception engine that was as good or better than human perception. But for me, that meant a close-knit, personal sort of relationship between hardware and software that was missing. And I thought that, if nobody else was going to do it, then I should do it.
A major aerospace and defense company wanted me to go to Silicon Valley and look for really interesting technology. And I remember Louis, he had a piece of tape over the LiDAR and you just saw this little red dot squiggling around and he said, "Oh, we got some bugs." I said, "I don't care about the bugs. You got the right idea."
I give Louis a lot of credit. His vision on building an active system that was smart and intelligent and modular so that innovation could happen at the hardware level without actually having to rebuild a whole new product, I think was right on.
My background, my training, electrical and computer engineering, optics and photonics, quantum optics, computational quantum physics. The overwhelming result of that experimentation, years of study and analysis, was that the hardware had to be software definable.
As an engineer, you always want the most efficient way of doing things. And this idea of putting laser shots only where you needed them instead of just spraying them everywhere just resonated with me as the correct way to solve the problem.
The most important concept and the one that will be, I believe, the most lasting is the idea of decoupling the path that the light for the LiDAR sends on transmit and the path where it collects the light on receive. That's really a stroke of genius and really is what allows us to have this flexible performance.
For the first time, LiDAR added to cameras and radar, I think are going to allow things that move or things that track things to move to really be better than humans.
We started a number of programs at DARPA in what we call biomimicry. Biomimicry is now a pretty common term for developing engineering systems by understanding how biology operates. The human eye looks at certain regions, it gets cued off of certain motion shapes, and then the human brain will focus more attention on areas of interest. And that's precisely how we've emulated AI.
The ability to scan with agility, the ability to focus where you need without missing anything else, and the ability to do it both in an extremely fast way, but also simultaneously in the appropriate size, weight, power, and cost profile that's needed for the markets is second to none.
Every shot, we can control the energy, the timing, the position. It's like a salesman gets to pick which airplane he goes on to fly to which city first. That's exactly how this LiDAR is configured. It's like, wow, it really is software defined.
You need flexibility, adaptability in a system. And so that's today the LiDAR concept and what we build.
It's going to be in basically every car that's built and still accomplish the mission of saving people's lives.
Why do I think it's going to be the right solution? Because it doesn't ask you to create the solution today or standardize on anything today. It just says that we know that there is the right solution out there, and whatever it is, the sensor will figure it out, or you will figure it out with the sensor.
If this is the first time watching the video, you're welcome to subscribe to the KellyOnTech channel and easily understand the global cutting-edge technologies and promising startups.